So I'm just poking around the basement workshop, looking for plastic sheet actually to dispense some more foam onto, but I've got this cardboard roof to Fiona's tower that was viewed this way, just peeking out of the curtain overhead, because you don't need the big pointed roof of the tower on stage. You just need it to be implied. So it's upside down. It was built with double layer corrugated cardboard laminations with bulkheads and skinned with cardboard. So it's like super light. It probably weighs 20 pounds. 20, not more than 30 pounds. So for what it is, but it's quite boat-like. I don't think we're going to use it for our ship. However, it may be able to be split and provide the majority of the front two sides of the hull somehow, because otherwise I've got to start bending things and provide support to that structure. So I may rely on this, and that's kind of the essence of what I'm talking about here. I'm just poking around, trying to see what we've got that might work for us without getting started building things from scratch. And I noticed these three panels, these 2x4 framed panels with structural members going in the short aspect rather than in the long. So as far as a piece of an 8-foot wall, that's what it is. It's just framed horizontally, but it's Luan skinned. I made those. They are painted black, I think, the whole way. That'll be the rub. This is, yeah. So it's this one. This is something else. I don't know what it is. Made with 3/4 inch material. Actually, here's another one, and here's a 2x4. So I got to figure out what exactly I'm looking at there. But I think for big wall panels on the turntable, so just rough backdrop verticals that will be built out organically with paper and become sort of like rock formations and stuff. I just need some kind of light duty foundational structural component, and I'm going to start with 3 walls on that turntable. So those are contenders that may need to be extended, but there you go. So I'm making sure of all of that. And then we've got people stuff that we're going to need for Ariel's grotto. And one of the first thoughts I had was this really crappy prop grandfather clock. It's sitting on the floor over there, so it's maybe 6.5 feet tall. Hey, is that me? Huh. 2015? I wasn't a student, so it must have been as one of my early shows. I don't remember that. Anyway, cutting something like that off at a relatively sharp angle, actually relatively shallow angle, so it looks as though it's stuffed into a sand berm that the stage encompasses it. So it looks like it's stuffed down into the stage kind of, and then I build up some paper around the bottom to look more like a sand, like knoll in the sand that it's sitting in, kind of upright but tipping over, gives it the impression, gives us the impression that we're underwater and that the stage is a soft, like I say, like sand, get at an akimbo, kind of a tilted angle. You could do the same thing with a piece of furniture like this, although this has got a lot going for it as a piece of furniture, so I hate to do that to it. But then we've got things that really suck, that are really simple, poorly constructed. I mean, maybe there's this. This is an institutional thing, and same with this. I mean, it's been around for forever. It served many purposes. But to cut a shallow angle on the bottom of it so it sits kind of three-dimensionally akimbo, and then build up some material around the bottom of it, all to give it that Ariel's grotto of collected human stuff, the big anchor pieces, and then there'll be more supplemental stuff that comes along later on. So I'm looking for things like that. I also got what I think is muslin. I think it's what you start with when you paint a backdrop, because it looks like it's 6 feet long, a nice big roll. And so to roll off horizontally and use it as sail, just peeking down from the trim overhead. Once we're looking at the front of our ship with our mast, and then we want sail coming in across the front of that. I think 6 feet is plenty tall enough to go up and well out of sight. And again, it would look and imply that the sail's overhead. And actually when they're pantomiming, like battening the hatches and getting ready for the storm, someone could take that out, implying that it's going up and out on the ship's mast itself. So we've got that roll of that stuff there. And again, I just want to check and see what types of things. I've also got, rather than building against balloons necessarily, I've got big cheap plastic spheres and domes and shapes like that. Trying to think of any other things that I was looking at down here. These have got like some details that look like they're, from the palace maybe. I don't quite exactly know what I will or won't need. Obviously, Little Shop of Horrors, Audrey 2 is here. But we've got those caps from Matilda that were on the gates to Cruncham Hall that have some, underwater ruins kind of shapes going on. This is the stairway that we're going to use on the other side of the ship set when we're on the ship, and the stage is the deck of the ship. So that's left over from Addams Family, and there's a mirror image of it standing up over here in the air vertically, but the wheels came off, so I got to pop wheels on it, and we've obviously got to make a route outside and then back in upstairs. So we get both of those stairways rolled in, and we've got the single rolling door upstairs, which I think will work for the palace. I don't know if we want to bother digging the rolling double doors out, which we could. We have before, and that's why they're there. I really hate to see them pushed all the way over in there. It's a really unhandy place. So, but they still have the wood plank look from Duloc on the front, right? With the big wrought iron hinges, which is kind of like a palace door from the era that this show is in. So it would be worth thinking about. And then we had, in our selection of tubes and tube-like shapes, these will probably work well for the mid-sprit or the something or other sprit, the pole that sticks off the front of the ship, or possibly going out the sides of the mast. I actually got the mast out of there. So let's go up and, I don't want to have to cut that thing off and use it as a figurehead, although those are getting to a certain point where, unfortunately, they came out of a renovation to a restaurant, and the contractors had smashed in the one's face and been really rough with them, putting them by the street as garbage. And if they'd have been careful, there would have been more of those there. But we used them for Addams Family, and they worked out okay. So, whether or not there's a figurehead on the bow of the ship, it's, remains to be seen. I don't think it's necessarily necessary. And so, yeah, this is a better size, I think, for the main mast. It's going to be a 12-inch diameter over a 16-inch diameter, which is our smallest tree, which, of course, looks relatively large compared to it. But I think the scale is going to be better this way. Same rolling base, I think, for it. And it's a 12-foot tube, which is what these started before we added 2 feet to the top of each one to go to 14. So if I need to get a 12-foot piece from Lowe's or Home Depot, or a 12-inch piece, they sell them in 4-foot lengths, I can easily lop off 2 feet and add 2 feet to it. And then I've got the base pattern for the smallest tree here, which will let me do two things. This will be the pattern for making more of the bulkheads that I intend to, create this effect by putting them throughout. So I figured I'd start with the smaller tree. So I'll make some copies of that. It's going to have, it won't need any of these holes, but it does need this big circle, which is the size of the tube itself that the tree trunk is. I'll have to cut outside of that a good way to avoid the heavy texture when it's getting slid over. Or, the other thing that I'm thinking is cutting it in half, making them in halves even, so that this shape, the circle, could fit down and land tightly, which is probably best for structural integrity. And it would also mean that if they're all in half, then either side of this construction in the end could theoretically come away in one piece if I used a stick between the bulkheads at like 3 points that rotated well enough inside of the texture not to show up in the texture, but holding them all together, and basically made a plan the way that I made a plan for these, so that constructing them all up and putting a cardboard skin on the whole thing, it ends up having good structural integrity. And in fact, I could even add some here. You notice this reinforcing, or this surface came over and stopped here, and it might have been stapled there, or should have been, but it could be glued up. And adding the three-dimensional structural integrity, notice how it's modifying and deflecting in those areas when you make those areas rigid. And then you come to do this, you've actually lost a good deal of that movement. And that's the type of movement that over time causes stuff like this to break. So the more, you lock it up, the better off you are, basically. So I'm considering, getting started transforming one of those trees into a stone column, and then making a base for this using the same layout. It helps me because it puts 3 wheel pans in an array that I know is stable enough. And I could go with the shallower ones, and I think I probably will do that, and the smaller red wheels that I put underneath that thing. These have full-size tall casters, but I honestly think that for most applications, those small casters are a better solution. In fact, I went with the bigger diameter pan, just shallower, because the 8-inch diameter needs to clear the big wheel swiveling in here. But as soon as you go shorter for the sake of a smaller wheel, the smaller wheel actually swivels a lot. The footprint of it, as it swivels around as a caster wheel, is a lot smaller. And so it was just because I had the 8-inch holes in this already, same the 3 that were in there, I just made the modification of going shorter on the pans, not smaller around. That being said, I have small openings here, and so I'll have to see if, because I believe these are 4-inch. Anyway, I'll see if I can get a shallower pan that would fit into this with a rabbet in it, and then I would put these into the base for the mast and leave these just from being cut whatsoever. And it doesn't matter that it's going to be larger than it needs to be, a bigger footprint than it needs to be, because of course that was a bigger footprint than the small and even the medium, and we could ostensibly go to an even smaller footprint for the mast. However, I think it looks its best if we set some cargo, some tall thin cargo around it, or wrapped some rope around there. And I don't mind having a decent sized shelf to do that, because it could only get a little bit smaller and still have kind of the dimension that this thing has. And then you really have a weird thing to try and get rid of because it isn't deep enough to set something on it enough. I don't know. It bears some consideration. I'm going to see as much as I can get out of having this geometry figured out already. I'll utilize it. I may end up making a completely custom thing here, but basically that could be used to handle a couple different issues. And so I'm working along on those things, as well as getting the coral prototypes down here to go along with the this stuff, the barnacle shapes that we're doing, and I'm going to work on an anemone kind of a shape now, which is going to be a multi-step process. So I'll see if I can find something better than a garbage bag to lay out and apply the foam, and then we'll cover making those as well as some of this other stuff. Well, I'm working on some anemone tentacles, and so this is going to be something I build in phases like this. I started with regular red great stuff, the OG here, and then I went to the Loctite foam original recipe that would be essentially the same use side by side, or apples to apples. However, you can see it immediately, it wants to build and stay fluffier. It doesn't melt down as much, which was really interesting to see right along through here and to there. And you've also got to pay attention to the fact that this can start strong, then you get into its stride for a while, and then it gets a little bit more fluffy right before it kind of falls off. And then I got into the Loctite brand Big Gap Filler, which is going to just automatically, or it should formulaically build up bigger. And so there's the contrast between being at the end of the one can, but also starting a new one, but starting a new large gap filler. So that, again, fresh can builds up, but also ultimately everything is bulkier overall, stays nice and fluffy and high. And then the can ran out here, and then I started with their window and door to make some of the thinner more spindly things, because I have a feeling that if it's anything like the Great Stuff window and door, it's a little more flexible, so they'll be a little less brittle, even though in the end most of it will break pretty easily. And so I'll probably spray these constructions with a nice base coat of something once they've been put together, to try and give them sort of a relatively flexible protective coating. I may even make that like creature cast rubber or something, so that it's got like a flexible skin that's thick enough to support it structurally a little bit more than just the foam has for structural support itself. And then I ran out of real estate, so I just poured out some spaghetti-o kind of shapes here with this stuff, just to see if it turned into anything interesting. So I don't know if that's half a can. So I think if anything, it's more wasteful. I like this kind of a plan of attack because we got 3 cans laying here, but I think for the volume that we create with this, it will be leveraging our investment to the max. It'll be the biggest possible, most interesting thing, given how much foam volume it has, where making something out of that is, again, a little bit wasteful, maybe more so. So there's also balloons and other shapes that we can use, which will be a part of this anemone, so that the guts of it haven't got to be foam at all. It's just air, and once the foam is set up, it can be popped. And that's another way that we'll maximize the volume that we can create by utilizing the foam at the outside, basically the surface finish. So I got those laid out to cure. They'll pop right off that plastic. I did it in this room where we aren't choking everybody up, although I want to get out of here now. And we'll put those cans in with the others, and we're going to keep track of all the cans of foam. But we'll leave these set up till tomorrow, and then I'll talk more about how the foam differs. I'm going to try and make sort of a reference for all the different types of foam that I use to compare and contrast. A lot of it is intuitive, or it follows a little bit, but some of these things are counterintuitive. In fact, the back-to-back foam comparison of the general purpose, I almost immediately like the Loctite brand so much better, because it just doesn't collapse while it cures off. But that remains to be seen. I'll get back to you. So one of the more complicated aspects of this set is going to be the ship, this piece, because we're looking at this, I think as discussed already, as though the stage is the ocean, and the sailors are, looking over the bow as the ship comes toward us, and then turning it around and adding the stairs and moving the mast out a little bit maybe, and the surface of the stage becomes the ship's deck. So it's a level, it's a glorified level. It's a level that they can look over one side of, and we turn around and they can be seen on the other side of it, and they can come down the stairs onto the surface of the stage. The mast is just essentially one of the tree, the same construction style as the trees. I show it having a tree root shape on this drawing, but I think, like we've looked at, I'm going to make a completely new rolling tube that's a smaller shape. I had thought maybe the smallest tree would work here, but it's too big, and I just as soon not go backwards and pull the bark texture off of anything. So again, we'll make a fresh one. The bowsprit is like an important feature to the front of this type of ship, and so I didn't want to completely actually flatten it, because you don't look exclusively at the exact front here. In the house, we come at this thing from the, a front variety of angles. So tipping that down, I think is going to help with this illusion. And I thought, just finishing the flat front of it maybe work too. But for that same reason, I've brought the actual bow point out beyond the constructed set and try to pull actual curves in, even though they're really short and flat. There are still actual curves happening. I think it's going to be an important part to this. And so we're going to actually be out here to more like 4 feet wide, and it really helps to have the mast separately because it really mitigates a lot of that depth, because we got to come and go off the set or out of the wings. A nice thing about this will be, however, that maybe the bowsprit is the highest point. Maybe it could flop all the way down, or maybe it'll pull up. Maybe that's a better way, because then the whole height of this thing is really at the top of the wheel. It's the last built on construction at whatever 2, 4, 6, 8, 10, 12 easily as this is drawn, but I'm actually shortening this just a tiny bit in a couple small places. So 12 feet will easily accommodate this thing off stage. And actually that's here. And so all the way to here, it's significantly less at 2, 4, 6, 8, 10 feet, and actually more like 9 feet here at the lowest point. And so a lot of this will actually go out into the hallway, right past the piano box on our bigger wing, which is normally where our bigger set pieces stay. So in general, it's pretty nice and flat, and it'll go right out into the hall, a bit farther than the house from last year. So all things considered, we're on a good track there, I believe. There are some considerations, because if you move into the 3D space with this is what we're basically talking about. The two major parts here is a timber frame construction done by 6x6 pressure treated, just because that's the only really easy type of 6x6 to get our hands on, to make a trebuchet type sort of timber shaped base. It doesn't matter that it's relatively heavy. It's more important that it's rigid and strong, but we don't have to carry any surfaces here, so it's not important to stick build. We could get the kind of strength we need by stick building, but there's just a lot more pieces to make, and it doesn't give us that secondary benefit of being easy to apply a surface to it, so we go with a timber frame for that. And then we've got a typical floor system for 1, 2, 3, 4 people at a rectangle. And then we're cutting the 5 and 6 person position at the outside edge into a triangle. We're taking the corner of that right off because we've got to get this curved bow to happen. And so I show the framing stop dead here. It would obviously, this is just initial, right? But essentially a floor system. And then there's one big hole drilled through this timber frame and a pipe that's overly long by a little bit, and a cap, and the same on the other side. Very simple, very low cycle movement here, so we haven't got to have anything other than just wood, steel, and physical, interruption there. The notch in this piece is deep. If I can move in on it here, it's the entire diameter of the pivot squared off. I don't know why it didn't. I didn't call it the diameter of that pin. Anyway, and so there's full engagement there, and it's just really easy to put up and take back down again. I expect there will be a couple places where we want to put it up there and take it back down. I don't want to have to support it and pin through everything. All the lower that I bring this framed floor down so that the pivot is into the meat of this side, the actual amount of wood that's bearing the loads out here is reduced further. And so I would rather be very safe with a nice deep notch. In fact, we're going to call this out and just fix the diameter here. That's what happened. There was no cancel. We need to work on the sketch, and we need to dimension this circle at 2, and then we'll finish it, and the model will update. We'll finish the edit, and then now we can move in and we can see that it's a full diameter, and then it's just straight down the sides. In perspective, yeah, right? So that's the idea of that. And you can build a seesaw like this and put a 1 or 2 more notches in either direction, leave posts in the ground with a pivot, and if you got a heavier kid and a lighter kid, you just take the whole assembly, the whole teeter assembly lever, and you just jump one notch one way or one notch the other. It's not a perfect adjustment, however. If we really run into problems here with weight, I expect we'll play more with where the kids stand. Anyway, they're supposed to stand on there, and it'll be pinned together for safety and rigidity for most of its use. However, during the shipwreck, the idea is, it won't matter. Perspective foreshortens things a little bit, but that it can move a little bit like this, and everybody can perform on top. So right away, we need to determine how much we want to see and how much is too much, obviously, okay? So we're going to, right to start with, trap this thing from going much farther than what we need to see here with some kind of physical stop. which, it shouldn't be too much of a problem because this entire area is going to be covered with a big fake bow. So we have the ability to build out inside of here to create that. And so I'm sure that'll be where we start. And then we're going to need to jump between this end and this end and hang down in this space kind of lower and create a pin to load with weights from the weight room. It's a nice way to do this for adjustable weight like that. I'll just make another pivot down here that stays inside, that rides back and forth. It's part of this framing component, but it keeps the center of gravity real low. And you can add weight, or take weight off until we get this thing dialed. But I can build that much and not have to change the construction of this thing. It'll be just kind of set up to dial that in. It'll make the amount of weight that we put up on here negligible when considered against the amount of weight that's below, so that when you unpin this thing and you want to move it, you've got 2 degrees of safety. You can only go about so far. It doesn't completely dump everybody off. We've got that bit. And we've got a low and larger center of gravity. So really all you're doing is making it easy to come out here and move, or even from in here halfway across this lever, well behind the front of this thing, for a crew member to hold it, or a couple crew people to hold it and coordinate their movements. Ooh, and we get, the last piece of the puzzle is that we can choreograph this. So first we go down on this side, then we go down on that side. The performance is happening up here, and ultimately people can leap off and what have you, and then we come right back to where it can be pinned through, and that corresponding hole you can put a pin right through there, and then take the whole thing and go off with it, or turn it around. So that's, what we're going to do here. And then when you turn the piece around and utilize it in the other, the kind of other major application for this set, it could be pinned, the stairs, and it can be used as a level. And we're gonna need some kind of a cabin surface on the back with maybe a door and a window or whatever to keep you from being able to see right into the set piece. But overall, I think that, with the bowsprit being able to flip up and down, so we can go off and come back on, they can put that up. With the mast being behind us in this angle, and then right around in front of us on the deck with another angle, being able to go upstairs, across the deck and back down again, and, spin the ship's wheel. Of course, it, will look as though the ship's wheel is, I'd like to remove the bow aspect of the set when we're looking at it as the stage is the deck, because the ship's wheel is normally at the back of the ship. And so we'll have a nice view of the ship's wheel, and maybe that's another application where we'll flip down the bowsprit, so we just see the ship's wheel and a railing system behind it as it would be there. And basically it makes sense in the other direction as being the back of the ship and the cabin and stuff that's at the back of the ship for the officers, etc. The side walls of the stairs are vertical, plumb, so obviously they're going to have to be snuck in here until they start, inside the curve of the ship, perhaps and perhaps not. See, we can get away with obscuring that curve of the bow as we open the camera view of the audience, basically, to be, looking at the deck of the ship. So there's something to be said for not having to respect that curve. However, in a bit of the choreography and the scene where we are looking at the front of the ship, right now, I think they want to see more people on board than just the 6th. So there's some talk of having a level down here where they can sort of be seen here or there or what have you. I don't know how important that's going to become, but we're going to need to make a commitment here to the visual that we're trying to create. So there may be an opportunity to lose some cast members from some ship's crew, ensemble cast from these scenes, but try to incorporate them to the other scenes to make up for it, all to get this set piece to work for 2 kind of major locations outside and inside a tall sailing ship. Obviously, we've got we'll bring in a bit of a sail on a bar. We'll probably end up having some ropes to either come in with it and then go back out with it, or any, some infrastructure here so that it can look like they're trying to fight the storm. So obviously the ship's wheel and stuff like that. So at this point, just talking a little bit about getting started to understand the fundamental structural pieces. I can make a lumber order with this after I add a little bit more material here. I know we're going up on some wheels. Most importantly, I got to come up with how we're going to build the counterweight and stuff like that, and the ability to pin it for safety. And then I'll get this much made as soon as possible so we can start blocking and utilizing it and relying on it. And then just at that point, we'll move forward, making it pretty and addressing any issues that we work out, because of course we're always building stuff for the first time. This is always sort of a working prototype. There's going to be things that need to change. So the game is, how much can you commit to and build so that you can start to learn what it is that you need to change or add. And that's where we are now. So stay tuned for this aspect. I got to get right into this thing ASAP. Okay, so I don't have physical interruption modeled here. I don't even really feel like setting that up, but I'll just go to where you can see those positive stops at a certain length, and it's trying to stick to that surface. But that's a reasonable amount of ship rocking in storm waters. That's reasonably safe. And I can always make these shorter, and obviously this isn't even real life yet. So that's been handled. However, to get to that point, I also realized that if I'm going to, I came out to those ends because that's way out from the center as a nice long lever arm. The farther from center, because I originally thought, well, after I hit that mouse, I originally thought that this right here is a logical place, how to show it, a stick mounted at the back here that just comes down and touches the surface of this post, is a nice tidy way of doing it. However, it leaves a lot of lever arm beyond that, and then you're loading that lever arm specifically, and if there are problems with that, then there are just more problems. So supporting it out here at the very end, it's still, then you get into the problems of stopping it at the far reaches of the lever arm and any kind of deflection that's happening in between. So picking a point actually about halfway between the center and the outside end, in my mind, is an ideal place to do it, and it kind of shortens the lever, cuts the lever action or length in half. So any problems from the pivot to the stop are mitigated, deflection problems, and from the stop to the extents are mitigated. Just a best practice in my mind. Without any engineering, I'm not doing any FEA on this, so it's going to be over-engineered. And that takes me to my next point, which is, you notice that, I might have gone in here in this direction between the front and the back stringer with joists, I guess, in this case. However, they wouldn't have given me an opportunity to load that framing anywhere but in the notch on the stringers at the front and the back. So I thought, well, cut that in half, put another stringer right through, notch the middle one, and then we've given it 3 points of contact over the course of this thing. And then I realized that I need to come down off of this framing in a way that's got angular bracing to the weights that are going back and forth, as I don't just want a long lever arm to the weight. The way that this works is that the weight wants to hang straight down, and every amount that we move away from straight up and down due to gravity, it wants to be pulled back. And so we're taking the end of that lever arm and we're using it to control the level of this surface. And so you really want to run down and brace that so that as we tip over and this lever arm is trying to come back with the weight on it, we aren't subjecting the lever arm to a lot of stress, or the connection that we make at 90 degrees is being stressed because it's got a small amount of engagement. As soon as you run out to the extents that you can, we brace that deflection out, and so we end up seeing the system behaving more like we want it to behave. So with that in mind, if I'm going to try to run at an angle down to this lever arm that's got the weight on it, we're going to start laminating that lever arm to like this middle joist, and then it's a thickness away. And so then if you want to run at angles down to that, if you're going to be on the back side of it, then they're going to have to be mitered and screwed edgeways into the edge of this. And so then I started thinking, well, just double that layer up, one that starts on the side of this joist and comes down, one that fills in the thickness of this from this joist down. Then you have two thicknesses worth of bearing for the weight themselves, and then when that second thickness is on there, the whole far side of this is coplanar, and then you can put your angular braces on the far side and laminate them right down the sides of this joist before they leave and make their way coplanar to the side, the back side of that lever arm, and just try to keep from bending or torquing anything here. Try to keep everything flat and uniform. So with that in mind, I started realizing that when that's running to either side, God, this fucking screensaver, when those are in there, and that lever arm is doubled up and it's coplanar on the back of the joist, well, that would be an ideal place to pin through to one of these timber frame verticals to control this thing. And we start thinking about how is this going to work. The weight pack is in the middle here. There'll end up being a surface here for the crew members to basically stay in this piece if they want to. And we'll probably use the cabin door to get in and come back out again. It just makes a lot of sense. And so anyway, then you got a weight pack hanging here in front of you. And so if it was just going to be one person who could pull the pin out of this post or the other, and manipulate the weight pack around and have an easy time of tipping these people above, and then have the pin ready, and when we have to come back to where it lines up and pin back into it, and they can babysit the pin, make sure it stays engaged, keep an eye on all this internal stuff, stay on board the piece. That would be an ideal place to operate that, but I didn't have anything against this post. So, long story short, I added a joist to just sandwich this post. So then we'll actually put the weight lever arm down this side and add a thickness to the back that rides coplanar against the post. And then the weight will jump forward. The pin will come out where we can load it up. And then you've got to have support on the other end of that evenly. So you got to go back up. And so I just replicated that scenario to sandwich this front post. And so this lever arm will actually be the same construction on either one of these, run down together as a double layer, be angularly braced, and there'll be a pin that goes through at the bottom where we can add or take weight away until we're comfortable with it, that works in one way or another, a lot like the bar when you add weight or take it off when you're lifting with a quick spring to hold everything, and that'll be kind of the geometry there. So anyway, you go from having two 10-foot 2x12s and a 16-foot to 4 10-foot 2x12s and the 16-foot, all for the sake of having what we need here. So it looks a little bit like redundant framing underneath a surface, but happily, I don't even have to now use 3/4 of an inch plywood material here. I didn't have to before, but I was going to. But now with such a high framing frequency, I can jump across this space one way or another in the field if I need to, but we can just use 1/2-inch plywood for a surface. And really the idea here is we want to see as many people on the deck as possible, and we may even add a person or two, even if they come and go a little bit but aren't there when the ship's moving. Like we were talking about, we want to see a few more ensemble cast members from that angle. However, we want that to be relatively low weight compared to that weight pack. So moving down in plywood thickness, even though we're adding a couple framing components, it's a trade-off. We're trying to keep that weight down. We're keeping the positive stops out in this area. And actually, if you notice where they engage, they tip in a little bit on their way down. And so they come close to the inside surface of that timber framed component. And so I can actually slap a block on there, and the same on the other side. That'll keep that from whatever reason it ever would probably, but be able to deflect past this and continue down that much more, dumping everybody off. It'll be a nice little place to just slap a block to control that aspect, and everything stays inside of this necked down footprint so that we can choose our angle and our curve for the ship. Obviously we could have been this much longer with our wheels, but we want this lower part of the bow to curve right around and have room to create the illusion of the ship. If we stuck out this much at this depth and we brought this in right to it, it just wouldn't have the same look, and it'll become clear in 3D space. We're going to take this corner and not only sweep back here, but sweep down from the deck. And I'm not going to bother modeling that in the computer. It would be a different sort of software that would have an easier time, and really it's going to be something that once we build the bones, we ought to be able to connect the dots in the field and get something along the lines of what we're looking for. So I'm just making sure I have an idea of what lumber we need here. I'm going to finish up building that weight pack, and then we'll look at that. Okay, so essentially, if we're moving back and forth like this, you can see that these 2x12 lever arms that were added to that floor framing are reaching down now, and between the two of them, if the cats could quit knocking things off of things, between the two of them we could have a bar and we could put various weight in there. We would have to move this thing out, tip it up beyond clearing these posts, and do an operation to switch the weight, so this these positive stops may have to move to be able to get this done. So there's some caveats here, because in changing the weight, we're trying to make it feel right and be as safe as possible. And so screwing those on and off and on and off again may become a problem. So I got to consider that. The other thing that I liked about this, though, I went with a 2x12. You know, you could say a 2x4, a 2x6, 2x8. Maybe that's all the more that you need to load it with a hole through it vertically. However, you want to remember that we're looking for a nice wide layout of attachment here. The bigger the stick, the wider the screw layout, the wider the group of points that's engaging with these long levers here at this transition at 90 degrees. The greater of an array you can make that, the more strength in that connection you have as you focus those all down together in a smaller piece of lumber. The ability for those to twist and rip is a problem. And that's another reason why we're going to run out with angular support. However, I liked that the collateral effect of being so wide is that down here with all the moving that we're doing, you're not seeing a situation like this occur where it's scissor blades, where someone could get a hand or a finger in there with all the forces at work here and have it crushed. You're never going to get there. They just brush by one another. Could you get pinched and stuff in here still? Yeah, a little bit, but it's not going to be an accidental crush or a scissor action that occurs in there in any case. So that was a nice protection. But one of the problems that I see now is it's actually the exterior layer laminated to this joist, because this joist is tight to the side of the post. That's the lever. And then we packed it out another layer to make a back surface coplanar to the post, but also coplanar to the back of this stick, so that we could slap our angular control arms on there. But the problem is, if we're trying to go from the back side up here to the back side of that, you could probably see this coming. If I'm connected there, I'm crashing into that connection here, and it doesn't seem to be. So for example, if you're watching the stop over here, it doesn't seem to be that if we take as much stop in this design as possible, we have any meaningful amount that we could be connected here with that angle before it hits the post. There might have been a cool way to have a happy medium where the angle brace actually creates the stop, but we won't know whether or not that's exactly possible until we've done a bunch of experimentation, and I'm not willing to plan on something like that. It wouldn't be wise. So what does that mean? I think we've got to swap the situation around. I think that this joist and this joist can't go tight to the post. I think that they need to stay 1.5 inches away, and the second, and that thereby the actual lever layer will go against the post. The second layer will pack it out again in this direction, and then you have the ability to strap across that angle without running into that post higher up, and you still have a reasonable amount of distance to load up with weight below. And once again, we have the ability to pin from the inside through these levers smoothly into that post when everything is aligned to lock this thing at level. And all of that can be done from one position here. But I think we need to flip these around. And what does that mean? Well, it means that this joist is moving out to this location, this joist is moving out to that location, and at that point, and given that we're doing all the counterweight stuff with those pieces, we basically don't need this central one. We can go down from 1, 2, 3, 4, 5 kind of sticks in here to 4. We scoot these a bit more in. We solve kind of all of our major problems with the function. So I'm going to make those changes to the model and make sure that I like what I see. And then we can get into a drawing space to give ourselves the fundamental ability to make this thing and start experimenting. There we go. I'm feeling pretty good about this. We get that back and forth movement. And again, these things are constructed now where the lever arm is against the post. It's packed out on the other side, so it's coplanar with these joists. And we can make bracing happen to the inside, where below that the cross member with the weight goes. And I think we'll be able to dial in the weight before we even add these stops and get a real nice counterweight. And I like that I haven't, the further down you go, the better off you are. However, you want to think about sitting in here and pushing the weight back and forth. It'd be easier if it's in front of you, essentially, and the lower it gets, possibly more of a problem to manipulate it. And then we have to have a hole through any surface that I'd slap right on these pieces. And so there's, problems with that, getting caught, getting pinched in there side to side. And so I just as soon have a complete surface here, and then enough of a distance between the weight pack and the surface so that we're not getting any pinching or interruption. So I'm keeping that a bit higher up rather than going as low as humanly possible. That is available to us if we run into a problem having built most of this, and we're really, one of the first things that I can do is go even lower with the weight pack. But for now, I'm not planning to do that. Further, one of the only problems that remains that I haven't addressed here is that if I'm highlighting this component, notice how or actually we could just open this. It looks like there's a lot of things going on here, and in fact there are in some ways, but we need to just open this file to look at this construction for a second and realize that this rear truss is nice and is stiff, and we've got a loop on the floor, but it's made up of these relatively complex miters. And so, what are my plans for that? Well, right to start with, I'll probably butt the ends of this stick in and pass with these ends. So these go right by the ends of this, because this angle brace will be a bit on the one and a bit on the other. And putting all together like that is better than landing this on this full stick and then butting this stick in and having degrees of freedom right there at that joinery. While I'm going to use some pretty nice big screws for this purpose, structural components, this is a better way to lap all of that together, but we still end up with this spindly little thing out on this multiple piece loop that could deform all over the place, especially when you're coming down to the floor in multiple places with wheels. And as those wheels traverse that landscape, it's coming in and out of a perfect plane. The surface of the stage and all the different bumps and lumps isn't a perfect smooth plane. And so when areas can dip into lower spaces or have to ramp up and over a high place with respect to the area around it, it's constantly flexing this loop at all this joinery, and it's manipulating this and it's manipulating that and everything that's on here, and all of a sudden you've got this jello thing happening that you need to lock up. And so I can't run out to the outside corners the way I did at the back as easily, because if I were to come from way up here like I did there, I kind of need to tip back and engage with this point, and I've still lost the control over this joint. It becomes tough to do much here of anything without really thinking. And so I think that to start with, I'm going to come off of this stick at an angle, and I'm going to go right up, and wherever I land on these braces, I'm going to tie that together 1-2 places there to make this stick relative to this stick. And we've also got the side to side that we need to remember to do, but I have a better time the farther away at the bottom that I get. So while I go out here, I can stay on this one to go back there, and this will become clear the way that I choose to do this. But it becomes a question of designing those braces or just waiting to see what I've got left over from making what I know I want from the 6x6 and kind of utilizing what's left over. So, there's a bit of both kind of schools of thought in here. I'll probably get a couple extra 8-foot sticks, and I ought to be able to get any amount of brace in here out of an 8-foot stick, and it's kind of the smallest, shortest piece. So we'll probably just go with, this is 3 pieces that you could do with actually we'll look at the drawing space, because I've got this dimension now a little bit. So you can see here that if this is 43 3/8, so is this. So the 1, 2, 3 out of a 12-foot piece, you could do these. Across the back is a 10-foot piece. So, perhaps it would be best, and these verts are a little under 60, so those two could be done in a 10, and this back could be done in a 10. And then each of these is the better part of an 8, so that's 2 8s. So 2 8s, 2 10s. And then I could obviously get these 3 out of a 12, but I wouldn't have these leftover ends. So maybe I'm better off doing this with an 8, this with an 8, and this one with an 8, and having the better part of an 8-footer having 5 feet or so left over after creating this, because the 5-footer left could be split into 2 2.5s and brace this vertical to either side. And then 2 8-footers, again, could be used from here to there to there to there. So I'm going to put a lumber order together here based on these dimensions with some looseness factored in for where I decide I need to actually actively support this thing, because it's nice to use the computer and to plan on everything staying nice and flat and all this joinery being immovable. But in the real world, we have to imagine that the more places that you butt things together and screw them together without lapping them over and stuff, the more opportunities for things to flex around and for that to translate out, even if it's just noise. Creaking and groaning. I really hate to have that happening with any of my set building. So this is the fundamental mechanical assembly for right now. It needs to be engineered further. It needs to be tested and tuned. It needs to have structural rigidity added to it, and we need to find out, how much force is necessary to do certain operations with it. But I can kind of get this far now and know that I have essentially the working fundamentals and just continue to develop it in real life. So at this point, like you see, I moved to drawing it and I get a couple sheets going to understand for communication the assembly itself. I need to turn on some things like notice how we're missing some lines and stuff here. Display options I can show, tangent edges and interference edges, which right away do more. It shows a lot of these places that interrupt. Actually over here, maybe I need to, it's unique thread and tangent and interference, not thread, I guess. Okay, interesting, those don't show up. See, and that's the thing about this is I've made these as dumb, solid model parts. This is all one solid piece. I didn't make all the different 6x6 pieces and stick them all together again. I don't need to for my purposes here. I'm not making a cut list or showing all the individual pieces. I can build this, from a general arrangement drawing because of my familiarity with the design. So I don't create drawings in my process that are exhaustive construction drawings for anyone other than really savvy people who are interested in thinking critically to break down what I'm doing. And that's not to hide intellectual property. It's just because I don't need all that exhausting detail. But in the future, if I sell plans or if I make them available to people for an amount, I have to come back sometimes and add more detail, show this particular piece is the same as this piece, quantity 2. And, I know that this has enough information on this sheet already for me to build this thing, but not for anybody else without a lot of sort of head scratching. So I'm trying to be wise with my process here. It's nice to not have to have so many people involved that I have to really get away from the work and do more of the drawing and designing so that everybody else can work with confidence from my designs. I like this level of the project where I can prove out a concept here and then I'm going to go and do a bit more in real life. So there's a lot more work that needs to be done in a bigger operation, but this is good enough for me. I'm fairly comfortable with this. And now it's time to finish up my materials, print them out, and try to get this much made on the stage, get it up and running on wheels, and find out what the next hurdles are going to be. Well, that was a lot more cans than I anticipated. But I think one of the key things I'm going to need to remember is just a plan to do 2 buildups. Because even though this tight foam big gap builds nice and high, much higher than, if I'd have done all of this and anything else, it would have melted out a lot more already. But the thing to do is to let this cure, or at least set up quite a bit, and then build a little bit more on top. So I'll leave it to cure up overnight and see what's left tomorrow. Well, unfortunately, there was some kind of technical difficulty at the elementary school, so their show moved here over the last couple hours today for tonight. And so I can't actually get anything done on our set, and rehearsal won't be on the stage. because they kind of needed to make sure everything was going to work. My tool stuff had been moved, and they're apparently using this for something. So probably add a little bit to that mirror frame with some spray foam, and then maybe move this tube before somebody runs into it backstage. I'm not quite sure what's going to happen here, but this is the type of curveball that happens sometimes. Oh well, back tomorrow. Something I want to mention here, because it may come into play, is that we are going to bring those existing rolling stairways into this piece on either side. And I had originally planned on bringing them in at a 90-degree angle, but we've actually talked about opening them toward the audience, and I think that's a great idea. We're kind of giving the audience this camera view of both the ship coming at you and being on deck. So I think we'll even use them when the ship is coming at you, and the stairs, rather than being tucked in behind, they'll appear to the side, kind of opened out. That's kind of what the side of a boat does anyway. This thing will be built to work with the stairs when they're actually being used visually. So since that physical aspect of complementary, geometry will exist for that arrangement, I feel like we would be remiss if we didn't take advantage of the complementary geometry on the arrangement of the set, where it looks like the ship's coming to you and the stage is the water. So we'll get the sides of those stairs, and I think this is where I may use the roof that came in for Shrek, that looks kind of like a boat now in the basement upside down. I might go right down the sides of those stairs with that geometry. Even if I supplement that, that'll be a nice place to start. It's lightweight. I have enough surface area. It's roughly the right type of shape, so we might get a head start out of it. I don't want to get too far ahead of myself, because right now what I'm talking about is, if we're going to use those stairs, do they go doot, 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 and then is the last step from the top of that set piece an equal step to the deck of this set? Or is the last step flush, the surface of it, with the top of this deck? Well, the answer is almost always the stairs stop a full step down, and the last step is the level that we are entering. When you build a floor for a house, if a stair takes off from there, but more importantly, if a stair arrives at that level is the last step up, and there isn't one flush stair out first. You see that once in a while, and you go, whoa, somebody really didn't know or had a very specific reason. So anyway, that would be the best practice rule of thumb. In this case, I think we're going to break it, because I know my stairs, I measured the real ones from the surface of the set or stage to the top step is 66 inches. And so it's only 4 1/4 up to the 70 1/4 here, and so it isn't a complete stair. So the question is, does the overall construction go up to become a complete stair, or does it come down flush with that top stair on those set pieces? And so I think that I've been to the top of those stairs now in real life, standing on the stage looking out, and I can tell you that it's nearly 6 feet up to my feet, and then it's another 5 easily to my eyes, so that's 11. And then it's 5 feet down to the house floor. So your eyes are at, 16 feet off the floor of the house. It is very high looking from up there. I don't like to freak the kids out if I can help it. They shouldn't be all that freaked out. There'll be a railing or a guard system on this thing, but I would be remiss if I went up and we had any problems from that. You can always cut things down, but I don't think to come down enough, like the 4 inches here or a little more, is going to hurt anything here. If anything, it makes it a non-issue that we've already ordered the 6x6 lumber, and it's been delivered and moved into the job site. And then all of a sudden, if I were to find out this vertical was greater than 1/2 of a 10-foot stick, due to going up in height to become a full step up, then the 10-foot stick that I've got, it would be a horrible waste to cut one of these out of. And so then I have to remove it from the site and return it and get something more appropriate, like 2/8, and then come back with those, or or 1/8, I guess, in addition to the 10 we've already got, and just leave the 10 and then lop off what we need out of it and have even that much more waste just kicking around. I mean, it may come in handy. We go down a rabbit hole. So I think the safest thing to do is just squeeze it down just a little bit. It may afford me something, make something handy, make something easy. Something may come to light as a result. And I was going to say, worst case scenario, if you wanted to go back up, all you really need to do is replace these two verticals and have drill a new hole if it really becomes a problem. It's a better case in reverse if you make them taller, and then if you really want or are having issues of any kind, you can simply cut the system down right there and you have everything that you would need. But something in my gut tells me that we can err on the side of caution here and go shorter. So I'm actually going to take the 4 1/4 inches, just really easy out. And I wanted to showcase this part in the project. I mean, this is when the rubber meets the road here. We're making these decisions. Where is that extrusion? There it is. And so we extruded 58. So if we were to come down to 53 3/4, okay. Oh, and the opening for the hole for the, or did we put that? It's not. This is all one part. This is a really sloppy model, but I can basically move that down. No. This is like all one part as far as the software is concerned, because I just wanted to prove out the geometry. I didn't need to exhaustively make every single part. So we're going to come from 60 down. We'll take the same 4. We'll just take an even 4 out. So we'll go to 56. That looks fine. And we'll close out of this. Don't have to. It's been saved. I'm going to update this. Shifts that down, as you can see. And since we're about done with these changes, we can get out of there. But since I forced that, we're still at 66 1/4. Why is that? Oh, because I didn't lose the quarter. It's actually the position of this opening that it's not the overall height of the post. Obviously, we just saw that the opening / pin that everything tips over is actually what justifies this assembly between this part, this upper part, and this lower part. They're locked on that center line. So the overall surface wasn't going to move down any more or any less than we actually moved the opening. So I can just double click on this here. I'm aware of it for my software users. And we'll do this, and we'll take the, why is that? Oh, that's the extrusion. We need the sketch. Oh, 20 some years of this exact software. You would think that I could handle it. So what do we need? 55.75. Finish, the edit. Seems to have updated. Close it, because again, we'd love to be done with this, and apparently something's changed, and now we're at an even 66. So now all of my other dimensions, have changed to suit that and reflect that, which is the nice thing about using software. And we'll use fraction, and I can put the actual center of this at a point on here as well. But I've kind of got what I need here now, and I can print this, and we can get started on the stage, and we will hopefully see that all of the decisions so far have been well made. Won't you join me? All right. We're getting down to building with the 6x6 first. May as well build from the ground up. It will give me an opportunity to put wheels on this part and more easily move this part around. And then when I build the upper level, it'll go on here and the whole thing will move. And it's just always better to have things moving as soon as possible, basically around here. Hence the material cart where we've got stuff there. So I lined it up. I'm going to use these fold away banquet tables that we've got here. These are probably the ones that were running in the cafeteria when I was a student here. So these stay in a closet, and they're kind of like for these types of things. I use them every year. They're extremely heavy duty, and they'll work well as a sawhorse and a workbench for this operation, and that's how I use them always. Sawhorses have their place, but I'm going to want to have this amount of support, especially working by myself. It's a lot easier to slide things around without tipping horses over and whatever. So we're working on these. This is the overall assembly. This is the component part I'm talking about starting with, but maybe I'll get a pencil here. I said already that I was thinking that this component would, got enough hands here, but I was thinking this component would go over in here, and the end of this one would be there, and so this would pass and this would butt, because then the footprint of this angle brace is a bit on this stick and completely on this stick, and it makes for a nice connection. But I'm going to be screwing through and into the end of that, and then from below screwing up into this, or possibly from above down into it, with these super long structural screws. These happen to be camo because the supplier I was at had 12-inch ones from Camo. You can have them from Fasten Master, which I've got some shorter ones here. They work really nicely for putting together these big timbers with just a couple, fasteners. You pay for that. These are, I think it's over $130, $130.50 for that box of 50. But this will go together like giant Legos between being planned out in the computer and minimizing the number of fasteners and multiplying their strength out. That brings me back to, I'm still toying with, should this piece at the back just continue as one whole stick for various reasons here. We're going to end up with, say it didn't, say this passed and this butted in, then you want to put the plate for the caster wheel across that seam just as a best practice, and the wheel ends up in that location, and it doesn't maximize the length of the footprint that you can have. And we've got the real issue that I expect out of this is actually looking at it from the end here, this loop and the vertical on it versus this triangulated truss with the vertical on it. The deflection here in these, spreading apart at the top or growing closer together as a result of there being 4 wheels under the 4 points, and then I think I'm going to end up with a wheel directly underneath the load, so that these points become a footprint, and it's not relying on this solid member to be a load-bearing beam in this direction vertically. Same as it goes for out here, because of course this one's compromised in that way. So right away, the load that this thing is on is primarily on these wheels. However, it will be split out through the diagonals, and if I end up bracing out here and out here, or here to there, it'll be spread around. However, the deflection that's possible in the two verticals, even though you've got that pivot, is kind of significant, because you're rolling around out here and all that weight is holding all 6 points to the floor, and as the floor changes and those 6 points change thereby, the structure above wiggles around. And if you've got a big tube strapped to it tightly to the component that tips, so that the mast tips with, because it wouldn't work if it did this and the mast stayed upright, it doesn't work visually. The mast has got to come with, so you've got this mast that's affixed to everything, and essentially the collateral wiggle and degrees of freedom like that are never good. As they are allowed to move over time, they work joinery loose and collaterally bring down the structural integrity of the assembly. So we don't want to see anything like that. And so right to start with, should I leave a 120-inch 10-footer and I gave myself a dimension as though I was going to make the piece go through there long, so then I'd have to pull the 5.5 inches off 22 1/4, which is possible, and make that piece instead, just so that this nice back triangle has got 3 nice points on the ground as a backbone. And then if I get the rest of this built and there's too many degrees of freedom or it's too spongy, I can start locking it up by going back to this triangle. If the triangle, in my mind, if it's compromised here at the end by being cut short and having this lap in the corner, it seems to me that it isn't as strong of a unit to start bracing this secondary unit to it. it's a bit of a difficult thing to communicate. I expect I could make it work in either case. So what I think I'll do is I'll start by making it one whole 10-foot piece, because that can be cut back, and I can replace the short pieces here with a bit of a longer piece, both from an 8-footer and possibly even from some of the leftover. So the safest thing to do, I think, is to err on the side of caution and make it all one full length and get to a certain point. And if I'm really pulling my hair out with this thing being rigid enough, I can investigate whether or not I want to try doing that, or if I think at that point I could rule that out and I want to just move on beyond it as well. If I go this route of passing this, like I was talking initially, kind of committed to a stick that's too short to try the other way around, and this is the thinking I'm doing now before I start making cuts, right? So given that, we're not working on this today. These components are laying over there in the 2x12s, that component. We're going to get this thing up, and then we're going to get some wheels from the basement pulled off of something else. See how far we get here. I don't have a tripod. It got locked in the downdraft room where I was hot knife trimming the foam back on the mirror frame, which is, it's starting to look the part, a long way to go there. Some of the key areas, the center bottom and center top, I think I'm going to do a little negative sculpt and then possibly build up a little more foam. I much prefer the left-hand side to the right-hand side, particularly in this area here. It's weak compared to that, so I may hack that up a little bit and rebuild it to suit there. I think that there's some negativity, like I opened these pockets up, I think that there's some more negativity that needs to happen in here by way of cutting that out with the hot knife. And then I'm going to try to form, probably recut more perfectly on the Sharpie line. Right now that's a rough cut. And probably do it from the back with the jigsaw against the flat surface of the foam so that the edge of it doesn't wander, which is what was happening with the knife, which is why I left myself some more meat there. Anyway, recut that opening and then try to get something with like a trim bead, like an OG or some kind of a trim profile that's more architectural and less sculpt, and get it to curve around to finish the edge. And then we've got the shiny side up on tinfoil, I think is what I'm going to use as a base for the mirror, on a sheet of Luan applied from the back so that the opening has, we maximize the depth that we gained in using the foam. Not only is the whole assembly nice and flat and not curving on us if it would have been on plywood, all the more after we remove the middle of it, very little bit of cross-section resisting that total curve. So the foam was a good move. We gained collateral thickness to the outside when it gets painted around the corner, and on the inside we'll keep that if we put the Luan on the back. Again, shiny side of the tin foil. You can always use the more matte side, I guess, but I haven't got any up. We used it on the windows last year. I can't remember. I think I'm going to use shiny side up last year. So after a year, the telltale wrinkles come back, but initially you can get it to lay down pretty nicely. I'm lazy with the spray glue. I know it does that after a year, and I don't care. You could use contact cement or something, or even rubber cement, and it would likely to stay flat for forever. We may experiment there this year, but anyway, start with that and then do some more, try to get the look of a real silver mirror, which tends to split, kind of like tree bark kind of texture happening a little bit. So try to get that real old mirror to happen there. Anyway, lots of things going on at the same time, but for right now, I don't have a tripod, and so I don't know how to pick a place to hold the camera so you can watch me do the time-lapse cut and fit for these. So right off the bat, being as smart as I can be, I got 8'6" on top of 10s. So let's just pull them off one at a time, turn them into what we planned on turning the 8s into as we move through the stack, as the order, choosing the order to do this. Beyond that, one of the two things that I know are definitely out of 8s are these either side angle braces at 78.5 inches from the long tip to the long tip, which is how I normally call something like this out. So I also gave myself a 43-degree angle here because really it's so close to 45, but the thing is we're maximizing our overall footprint. 120 inches is a full 10-footer, and so going from the ends of it flush to flush with the overall height of this stick that carries this elevation of this opening for the pipe with enough meat all the way around it in such a way that the notch is a full diameter squared out, as we discussed, of the sidewall of a 2x12 that has a surface. The surface is what I measured to when I went to 66. There's a couple ways around here where we can get thrown off a little bit like that. 66 is here. And so all that framing is based on the frame of that floor for the ship piece working out exactly flush. And then you put plywood on 1/2 inch or 3/4 inch, and actually the floor of the ship will be significantly higher. In set building, most of those things, when you see them, are just like not a big deal. However, I just called everything out there to mean that it would come in exactly flush to these pieces, and I'd like to do that if I can do that. And the other way in which we run into trouble here is you get all done planning on something, and then it needs to be a little bit off the floor, or the overall height of the caster varies, or in a lot of cases, this is an aside, however, the caster, so that it clears the sidewall here, can't be actually under the corner of the framing itself. It's got to be moved in so that in turning around, it doesn't scrub or break the plane of the surface of the framing. So many years in a row now, I've utilized these triangular plates, plywood, applied to the outside corner, and therefore, when you justify the plate of the caster to that hypotenuse, you can be sure that that caster won't break the plane of that outside corner, but that adds 3/4 inch in thickness between what you plan for in framing and the floor when you account for the total height of the caster wheel. So there's some tricky business that you want to remember there. And so I just kind of uncovered live the fact that if I'm going to add a surface to this set, it's going to be that much taller. And so it doesn't matter that I'm not using the triangle plates underneath this set piece. Those wheels can break the plane of this because the entire skin of the bow of the boat hangs down well in front of all of that. And you know, these faces and facets won't have a surface applied to them that's a visual surface, or at all. So that being said, I was about to say that these pieces were called out as a product of being flush at this point and flush at that point with the ends of these that are based on how long they have to be to get that thing to be there, to be the height of the whole thing, which I see now needs to be a little bit massaged. However, that's why we end up with a 43-degree angle here instead of a 45. So the other part of 90 will be necessary on this end. So if that's 43, it'll be 47 degrees over here so that we can build the triangle that is ultimately a 90 in that way. It's just the way the geometry works, right? So here's one of the problems. You can't just round that and make it 45 since your speed square has got that angle right on it. Right here, to justify it, if you see here that the 45-degree line is this middle one, all drawn from the same point over here. All three of these lines converge there. There's some line weight going on and some marker because I know what I'm going to cut already. But if that's 45 in this piece, which is the piece we're going to keep, which we're going to make right there, if it's 45 in this piece, we need to see it at 44, 43, for that to be the angle that's on this piece, because that's what we're talking about being on this here. Now, we need to be at 43. However, if you use your speed square to create that angle, I just picked an arbitrary point just a little bit in from the flat end of this because it's kind of rough. And so you tip the square off around whatever point, and you watch, you go to 45 here. See that? If you go to 45, you find yourself on that middle line. But if you go to 43, right there, a couple marks in from 45, you go to 43, you find yourself on this line outermost line. So if that's 45 in the middle, then this is 47, the other part of 90. So why is this saying it's 43 when I use it this way? Because a speed square is meant to work in conjunction with a miter saw. And when you go to the miter saw, and you put a piece of material in to the fence, the blade is already at 90 degrees, and then and the angle readout is correct, but when you move away from the blade's at 90 to the fence, but the blade is also at 0 as far as the readings on the saw. So when you move to a point off of 0, you're actually leaving the rest of 90 degrees in the material out by choosing how much to take out as a number from 0. What you're left with in your workpiece is the other part of 90. So since when you go to the miter saw, you're actually calling out the negative that you want to remove, leaving your piece with a certain angle on it, the speed square is set up to give you that reading. If I go right here to where I want to be, because I know that's the smaller and more acute angle than 45 there in the middle, this square will show me 47. Because if I go to the saw and I set the miter saw, I start at 0, even though it's actually a 90-degree end on the stock, and I go to 47, that's defining the part that I'm going to cut off, and it's the 43 that's left on the stock. The miter saw and the speed square angle tool are designed to work in conjunction, and they're really both discussing the other part of 90 degrees that you intend to remove. And so this right here, looking at a drawing, going, I got to put 43 on there, and I know how to use a speed square, and I've even done this to myself before, and I go to 43, and I put the line on, and in that case, it would have made a 47-degree angle, and there would have been enough left to recut and actually fix it once I've taken it off on the floor, and I'm pulling my hair out trying to figure out where my angle's wrong. This is why a lot of framers, a lot of trade guys, a lot of construction guys that are earlier in their career and are real skilled in a lot of other aspects, but you start getting into roofing or any kind of angle stuff, and they pull their hair out, they get really angry, they remember not liking math in school, and they just don't like angles, never liked angles, or that type of thing. This is the reason why. And it's a kind of tough thing to communicate, but I think I ran into it last year real quick and called it out on the set building video for Matilda series. Anyway, here's how it works here. So, and the drawing will tell me exactly what the angle that I want on the part is. So I just need to remember that 43 and 47 are either part of this particular piece, and we'll put the one angle on the one side, the one angle on the other side without rolling it over, and we'll make ourselves one of those. Then we'll do it again and make the second one, and then we could get into a more meaningful path here. But you notice me running around getting set up and, making sure that I communicate this. Now I've been here for a little over an hour. So, and that's another point of this. I don't charge by the hour on this project, but and reviewing these concepts aren't part of my billable time either. However, there's always a lot of work just to get down to laying out and making the cuts, and it can get lost in the shuffle sometimes. So particularly on this project, I kind of do almost everything myself. I take as much advantage of as much help as I can get, but I want to work as smart as possible here. So now that I've discussed that, let's get to ran to the store and got a fresh Sawzall and circular saw blade for this. It's not going to hurt anything. In fact, it was hurting me not to have one, and an extra long 1/4-inch drill so I can get those holes through the 6x6 for the pipe. Get them right where I want them. I'll go through the whole thing with this, no pun intended. And then I can come at both sides with a hole saw or a Forstner, and hopefully meet up in the middle somewhere, since we're both pulling on the same drill op that went right through. Even though it may go through just a tiny bit off, more importantly, we need a concentric or coaxial set of holes because we can't drill all the way through at the full diameter, I don't have a bit like that would make sense to do it that way. In fact, if you did anywhere but on a drill press or something, you're going to have it twice as out of control. So you can cut the accuracy of the operation in half, or double it really, by cutting in half the depth from which you try to drill all the way through. You double your accuracy. So anyway, I got the stuff that we needed. These things, if I had any, are in the other set of tools that are still on the job site from the previous project. So now I can actually, and I got a little Red Bull here because it's going to give me wings. Somebody dumped something on the floor just there. I was stepping in, it was sticky. That's not me. So let's actually do this now, get this done. Okay, this looks good. Another thing I like about using the stage is that it's all 4x8 sheets of material. They were applied symmetrically from the center line out, and so there's basically a grid on the floor, and I can use that to my advantage. Something if I had my way in my own workspace, my own large workspace, I would do that again someday. Right now, my workspace at the shop has got 1 foot by 1 foot square tiles, which, there's a benefit to that again. So anyway, using the straight lines on the stage, obviously I got this seam right on the sheet, and I went there with the bottom of this post, and I went there with this seam as well, and I've closed the joinery, and I've made everything kind of flush, and maybe that could come up just a wee bit there, and maybe that'll become apparent when we find out that it had to tip over. I don't know that the location of that is exactly in the middle of this assembly yet, but we'll probably get close in getting this all dialed into flush. The last thing we'll do is connect that. However, and I got the screws here, but I'd really rather put the hole all the way through this post before it becomes part of this assembly. And so I want to know its location exactly, so that if I stick to my plan for the next piece and I build this and the notch goes where it's planned, and then I put a sheet of plywood on top for a surface, that surface is exactly flush with the 66 inches from the floor that existing set piece, those stairs are. We're going to use 2 sets of stairs, by the way, but and so for that to be the case, and I don't want to make any more of these components until I get a sense of, like, this is the fewest number of 6x6s that I could chop up to get to a point where it makes sense to screw it together, and therefore I can run into any problems now and make modifications to my process going forward and mitigate error or loss or sacrificial material. So I want to screw this together, so I want to put that hole in there, so I want to be absolutely sure of my stack up to the hole location, so that I can definitely count on that thing being at the right place. I kept all these components the same size. I'm just going to vary that hole location a little bit. Now you could say it's that 3/4 of an inch that I was off, but now's the time to make sure that the plans, I counted on 5.5 inch height caster. Actually, one of the easiest things to do, because we only have the 2 or 3 different major types of caster around here with different overall height, so that we can count on their quality as well as we can count on the geometry. And so I know I'm going to use this type. It's on this piece. And so if I go to the bottom of the plywood, it's actually 5 inches off the floor to the bottom of the plywood. So you know what else? I have no wheels in the model. So we've got to be careful of this whole situation now, because see, I've got no wheels here, and really there needs to be 5 inches for the wheel, and there needs to be plywood, and that needs to be 66. See? So we're going to have ourselves in a real bad way here if we're not careful. So that means we got to do some figuring. And a lot of times I do these layouts by hand, and then I just sketch in the wheel. I never want to model the wheel, even though I could really quick. And so here's where it bit me. And I've learned my lesson here several times, but you would think by now I wouldn't be at this point in the process, because basically this whole thing is going to get a lot taller than planned, and so the hole just needs to move down a bit, which at the end of the day, not that big of a deal. Kind of like the hole to be, so in a given post, to center it, there's a certain amount of meat to either side, and then you can go all the way up until that same amount of meat is kind of over the top of it. So it's kind of in the center of what would be the square of the width at the top, and then you pick your overall height. So I think I'm going to move down here quite a bit. It'll probably end up being, well, 5 or 6 inches lower than I had planned, which will put the hole here. So, it won't be low enough to where this geometry at the top is crashing into the framing here, but we're going to end up with what amounts to more like a situation like that, with the hole lower down, I believe. And then this will still pivot real well, and it shouldn't interrupt anywhere there. So that little oversight, I don't think is going to, we went in the right direction by omitting the wheel. You know, if we're going to make an error, that was the error to make. So I'm going to go take the wheels off that set piece in the basement, bring them up here, and get that far, and continue to try to ensure that the surface on this works out to 66 inches exactly. And then we can commit to the hole drilling, and then we can put this piece together and keep moving. So the 66 shown here, based on this geometry we've already created, is going to grow by 5 inches here, and however thick of a plywood sheet we add there. So say we're going to go with 1/2 inch like we were going to, or have been planning. So 5.5 inches is how much this has grown overall, which means that if we built this geometry and the hole was supposed to be 50.25 inches from the end of this stick, if we take 5.5 off of there, we can go to 44 and whatever, 3/4, whatever. And that'll be the new location for the hole. So I'm going to put that into that stick and make sure that goes relatively smoothly. You know, the other thing I was going to do is get the pipe first, so that I know exactly what hole saw to use, that it will definitely go through but not be too sloppy in. And I've got to have it work out so that it's got to go through this entire thing, which is 36 inches, and then put a cap on either end of it to kind of keep it from sliding through. So like a 38 inch. Yeah, we're going to have to find that situation first, because we need a large diameter finished piece with threads on both ends. So we may be stuck. Well, I can drill that pilot hole through the whole thing, and then just keep moving and assemble this, because I should be able to do that hole saw operation in the air from both sides. In fact, that would be probably how I would do it. So we'll plot that hole and drill the hole, and then just keep moving, assembling here. And we're gonna remember to get that pipe situation handled so we can get the hole saw picked so we can finish drilling the opening. But had to think about that out loud. So yeah, let's move that down 5.5 inches, drill through the whole thing, take it back over there, and then we also want to avoid that hole, which this may work out in our favor, because before, if we had the opening here with these corners and we were trying to screw through here, hang on. So if we were going to try and screw through, really rather do that actually. Something like that, and like that. What am I looking for here and there? So unfortunately, one, side by side basically on that plane. So we would have been better off with the big hole up here. I have a feeling that that's going to be right where we stupid need to be at, what did I say, 44 1/4 or 3/4. Yeah. Right at the confluence of fuckery. That's an ideal way to pin those. I can do this. I guess it doesn't hurt anything. They may run into one another is the only thing. So I guess I could go to like one above, one below, like at an angle here. So for this side, shoot, that's the thing, is it's going to maybe come out the other side. So I have to go like here and here at an angle, and the opposite angle on the other side. And all of that will keep this clear for the opening to go through it. And, in the end, I guess it's kind of silly. I really got to look at that, because we got to put a 2x12 deep, 11 1/4 inch deep floor system on this thing. And now that these are out of the way, if we go to 44 3/4 and we go with a 2-inch diameter hole, and then we go from here to up here, we're almost bottoming out 11 1/4. Yeah, I mean, it's just gonna miss. We're kind of consuming the entire cavity. That bottom of the plywood surface is going to be here, but in pivoting around that point, I think we just miss. I could certainly hack this shorter. Not to mention those screws are going to be down in the lower 2/3 of this overall joinery, so I could take a couple of inches right off of this in the event that we end up needing that. So I'm just going to remember, I try not to be, I really avoid completely showing everything in the design, because there are so many things that change in the field that it's foolish sometimes to get ahead of yourself and plan on everything. However, this is a case where I erred on doing a little bit less so that we could get in here and start building sooner. And I just have to put this much time into being careful now not to screw myself in any of these simple little stupid ways that you don't think about. So if you show the screw that you plan on, and you show the wheels that you're going to use and stuff like that, well, I can show the wheels because we use them every year, but these screws, I didn't know at all that I was going to go with these, because they just ended up being what was for sale at that hardware store. And so anyway, I didn't model and show the layout of the screws and all of that in the model, because it just gets to be really silly to go to that detail. But say you had, you'd have found out exactly what you needed. And if you did all that, you could even get a number, a count. It's very specifically on everything, but I shoot down the middle in that because there's only one me, and even if I were to plan perfectly, the things that didn't work out being available or not being able to get that size, and the confidence that you have in planning with every single part shown in the model to, thread the needle and dial everything in a lot closer without more degrees of freedom or margin for error. Then as soon as one small thing isn't something you can get or wasn't the way that you planned it in the model, it can actually have a cascade effect on kind of ruining all the things that are planned peripherally around having that. And then all of a sudden you're in a position where you have to go to the ends of the earth to get that thing versus changing a lot more of the design than you would realize to work without that thing. And the time starts spiraling out of control, and there's just real no good way to create or destroy energy. Basically, there will be a certain amount of thinking that needs to go into everything. So, I make my peace with that, and, I'm pretty transparent about how these things come to me in the middle of working. Yeah, you could exhaustively have, found this all out in the model space. In fact, there's a degree of this that I should have been more aware of just with my experience, but I'm making an example now of being sure of when you're actually using real material in real life, that you're making checks like this before you just go building a house in the middle of Sherwood Forest, a la the Bugs Bunny cartoon. I forget the name of it. Anyway, he tricks the sheriff of Nottingham into buying and building in the middle of maybe the King's Garden or just Sherwood Forest. Anyway, he's practically done with the house before he starts thinking about what he's done. I try not to get into that. I want to make sure I'm not being stupid. So, stupid check over, and now we can keep moving. So at some point recently, because these wheels aren't all that old, somebody bolted them up to this truck diagonally with carriage bolts, and it's just nothing that I can really say. I mean, it worked just fine, right? So what am I complaining about? Well, I like a lock nut. I mean, this is the type of thing that once this is facing down, once the truck is facing down and you've built a set piece on it, fortunately on our stage you can roll out over the trapdoor or off the edge, actually any stage over the edge, and you can address a problem wheel. But that's way easier when you have more than 3 or 4. When you only have 3, obviously you can't do that at all. And when you have 4, it gets really tippy, and you got to go to more lengths to support it while you operate on one wheel. And really the best thing to do is to just put the wheels on in a very reliable and safe, secure way. So I like little lag screws, little lag replacement structural screws, which is what we're going to use on that thing that I'm making upstairs, the ship, because like a screw, I'm relying on the material, the wood, to squeeze and draw down, and it'll be just fine with that. It's fewer component parts, less accuracy required, fewer tools. I haven't got to drill and then hold the other end with a hammer, or actually hold it with a wrench. In the case of the carriage bolts, they have a square part that pulls into the wood or the soft material, and then it won't ever turn until it does start to turn, and then you can't stop it from turning, and then you need a different hole because you need to pull that square component of the carriage bolt back in to the material to stop it from rotating again, and now you've moved your whole location, and things, get crazy. Same thing can happen when you remount a screw hole if you're attaching and reattaching. I wouldn't do this. I wouldn't have all of these old, twisted up, dry and crispy, non-standard construction flats and trucks because that lack of standard will just bite you in the ass all the time. But we have got all that, and so many of the other shows and plays and stuff that I'm not involved in, and they haven't got a professional involved in, they rely on all this pre-existing stuff, and they kind of scab it together, and they, make something happen in that. So we can't just get rid of all of it, but because periodically they borrow the stuff that I'm going to come back for the show, in my mind, like those $60 or $75 each caster wheels, maybe at least 50. I always have to kind of deal with their weird kind of stuff like this. So no harm done. I'll shove that back in there. Now we've got some wheels, and I could go up and put those on, although I haven't got those structural screws. I'm really getting into a point today. I decided I want to use the drill press to drill through those 6x6s. I don't think there's any benefit to avoiding it when it would be practically super easy. The wood shop down the hall has got a nice big drill press. It's a floor model, and I can bring the table down enough to easily do that operation and basically just reap the benefits of that setup. I haven't always got that. I was planning on doing it by hand, but really, if I make a mistake or there's a slight error, it'll just be annoying. I'll bite the bullet. I'll do it on the drill press. Can't get into the room with the drill press today. Can't get my hands on the key. I got the wheels, but just realized I don't have the screws I want to put them on. Not only will I use the really nice Rose brand wheels like I try to put on everything now going forward, I want to use brand new structural replacement 2 3/8 Fasten Master ledge lock, not the however many year old mini lags that I'll show you, because I have had those break off, especially when you come down to the end and the impact driver starts wailing on it, and the head just twists off. So what I'm saying is, if there's still a head on some of them, but it's about to twist off because they've been run down tight and loosened and removed half a dozen or more times, I don't want to use them to put the wheels on this piece and trust them to roll around and be sweating that under any circumstances, let alone sitting in the audience all 3 nights and just hoping we don't have a failure. These caster wheels, I can't overstate this enough, making the investment to have nice smooth ones designed for this purpose. I don't know if I showed you, we already got this problem. This is one of the McMaster car, which they normally deal in quality stuff. Sorry, I'm huffing and puffing. I'm always a little out of shape this time of year after the holidays and sitting around eating all those cakes and pies. There are things like these handles for the trap door. They didn't used to be like this. They used to be round stock D shape that would pull up. There was a little finger divot to get it hold of it, pull it up, and you'd have all 4 fingers in it, and it was really comfortable. Then they resurfaced the whole stage, and they put these in place instead, which do fall down. They're recessed. It hurts to pick this up, even me. The students don't like doing the trapdoor as much because you can only get really just 2 fingers in there. So you get 1/2 of the clutch power, and it's just more painful. And it also makes a circular divot for the smaller the wheel, a bigger wheel. We all know this, but I like the sound of my own voice. I like hearing myself talk, guys. It's not true. A bigger wheel, zhoops, right through there. The smaller the diameter of the wheel, the more likely it's going to get stuck in there, and then you got yourself an issue. Not sure if that's what happened here, but we want to be careful. One of these got, really more importantly, when you look at this, you notice that the black core broke, or was overloaded. The amount of point load, the amount of weight placed on one wheel was too much, and it broke it out of the black center. And then it wouldn't rotate because the tire could go up and scrub the swivel plate. So not only are you having a problem swivel, but you're having a problem rotate, and then it just stays there. And then since you're really forcing the rest of the thing, it starts to scrub and ultimately sand a flat spot. It just gets harder and harder. It was making this whole thing practically impossible to move, and I was really throwing my weight on it just to sneak it off the front of the stage and take this down. So what are we going to do? We're going to pull the other 5 off. I called McMaster and said, I don't know what these are supposed to take for weight. They said 100 pounds, or 90, I think. But the thing is, they call it 100, and that's a rating, so it should take more than that. There's 600-pound capacity on that whole thing if there's 6 of them. And I don't think we've got 600 pounds here. We've probably got 300 pounds. 2 of these walls are 2x4 framed, but all 3 of them have Luan 1/4-inch plywood. The one is 1x framing, so it's, if anything, it's a little bit lighter. There's a couple old trunks on this, so more likely one of the heavier students was on it as well with their weight. So we're going to pull those off. McMaster sent me a replacement for this one that failed. It's somewhere. It's in the back of the car, I guess. I gotta remember that. So we're going to move from Rose Brand, which supplies those big ones for professional sets. That's what these are as well, I believe. I didn't build these steel frames. I talked about them last year when I got them around from Matilda. They had these wheels on them, but the guy that built these did apparently get these from Rose Brand, and they have been really nice, even though these things don't weigh a lot. They're a little taller, but I think that's okay. We'll have a little bit more gappage underneath that. How much taller are they? How did I get on this side? I'll come back, I promise. We'll circle back. But we're gonna go to this style wheel underneath that set piece. So if we're off the floor like 1/2 inch over there right now, we're gonna add 1 inch in this. So we'll be off 1.5 inches. So just have to live with that. It'll just be what it is. It's higher than I wanted, but that's how the cookie crumbles. Then these smaller wheels, they can go in a base for a small tree. They'll work well in these cake pans still as planned in that way. As long as it's not a lot of weight, no problem. You still want to worry about the little divots in the stage. So that being said, you want nice casters. You want just 2 or 3 different sizes standardized for that you're going to use. These are going to go right onto there. And again, I haven't got to worry about them breaking the plane of anything because we got a lot of margin for error here. This isn't any kind of final geometry. It's just structural geometry. And so I probably will move a little bit away from the end just so that I don't have a weird crack that occurs. But we'll use these headlocks. I'll just go to the next size down, the 2 3/8. They're a nice, heavy leg replacement, and they'll be brand new. And they're soft in the sense that they are more like a nail, and they bend all up and can take a lot of impact, and you won't snap the head of it off, unlike these, which are in circulation around here a lot for putting wheels on and off. But once again, sometimes that hex head just snaps right off. And then if we're only putting 2 fasteners on each wheel, so we don't have, and that's another thing. I'll probably use all 4 holes in these caster wheels simply because this is a piece that exists far more on a ragged edge than some of these other ones. Don't want a wheel to go down in any case. Here it's not a safety concern. Here it is, and massively. So, as well as not spiking this set piece with more than I really don't want to spike the set piece so that any of those wheels live on top of the trapdoor, especially with students during the performance. I want to be up or down stage from the trapdoor to where, and this is only 10 feet long, so I've either got to be fully behind the trap or fully in front of it. I really hate to be right on the trap because unlike the rest of the stage surface, that's just 2 inches of plywood door on nearly a 4 foot, on a 4 foot width span. So I don't love the idea of putting, 1/2 ton in 3 places, basically, 400 or 500 pounds. It's hard to crush the math out. Anyway, I really don't love this whole thing being on that trap. Maybe we'll have to, and so we'll have to do some engineering testing or just putting some people on it, me going underneath and listening to the whole thing and seeing whether or not I think there's going to be a problem there. That's the nice thing about wood is you can often hear it getting close to its engineering tolerances for structural strength long before a failure. You can hear crunching and creaking, and so we'll listen for that, I guess. But all of this is on my mind, and I guess right now I can't do a damn thing anymore today I'm not going back to the store just to come back and put wheels on, and I don't necessarily want to build the other pieces, although maybe that's the best thing to do. Yeah, at this point, it's in committing to this much, I'm committed to the whole thing, kind of. So I'll make the other pieces of 6x6 and then see where we're at. So I got a little more than half of a 8-foot stick left that we'll obviously use as a brace. Yeah, almost 5 feet. And almost 3, a little more than, well, a little less than 3 if you need a flat end. So, not a bad place to be. I'm looking more critically at the 12-inch fastener and thinking, 10 might have been more useful. In fact, 10s and 8s would actually be better. At that joint, same here. I'd really rather go at an angle. As soon as you're going into the end grain directly, you really end up losing structural integrity with the thread, because you are cutting into the sidewall of any given group of grain. Whereas if you tip it like that, now I'm cutting through, if this grain is vertically standing up in there, now I'm cutting through the sidewall of many, many more times any given grain tube. Of course, it's all like a group of straws, the grain being a group of microscopic tubes that make up the flesh of the wood. So rather than just running along a half a dozen, down through the core between a half a dozen, perfectly straight and cutting into the side of those few, as soon as I go out through all of them, essentially where we're talking about thread, I guess, you end up, each thread is in an entirely different vertical group or otherwise aligned group of grain, and you end up with many times more of the attachment power. So a lot of people would approach, a button, a pass like this or over there, based on the outside shape, geometry, their alignment. Really, when you're building with wood, you want to think about what you can do to maximize the holding power, considering the grain direction. So that's where you get into, like, a 12 would work nicely here, and would be safe not coming out the other side at about a third across this joint. And then another one would actually be more like a 6-inch. So if I went to 8, I'd probably be more like there. And then the 12, could justifiably be there. Or excuse me, a 10 would be more like that. So 10s and 8s, I think, are a better bet. Certainly don't need $130 worth of these 12s. I might get some individual sale to, like, half a dozen 12s marked for individual sale at $3 or $4 each, or whatever they end up being, 2 or 3 anyway. But the pack, I'd probably get a 50 pack of 10s and some 8s. I don't know. I don't think the 12s are what I need. So before I go even scuffing the paint off of any single one of them, I just have that little bit of inspection. Anyway, the rest of the components have been made, and they look to be set up nicely when dry fit onto the grid on the floor. It seems that the angles are all correct. The verts are here, marked for hole drilling. I'm going to do that on the drill press like I was saying, and then I can follow through with just the hand drill and the hole saw once I have that nice through hole for the pilot bit. And while we're getting the right construction screws, we'll get the ultra shorts for putting the wheels on. And in that way, we ought to be able to put that whole thing up on wheels, drill the holes through it, put the pipe through, and cap it as a pivot, and then look at what we need to add for bracing for structural integrity purposes. And then get a couple more 6x6s, most likely, to do that. But I'm at an impasse here, I think, today. 4:30 on a Sunday. I'll probably go spend some time with baby Hank and pick this back up again tomorrow.